I want you to turn into your study guides to measures of spreads, and we're going to talk about types of measures of spreads when we're talking about the features of a particular distribution. Now, first of all, what is variability or spread? Another way of summarizing a distribution of data is by selecting a single number that describes how much variation and diversity there is in the distribution. So when we're talking about spread or variability, we're often talking about how much diversity there is among the data. Is it consistent? Is it inconsistent? And we want to find measures of this diversity or variation, and we're going to study the different types of measures of spread and variability that we have. Numbers that describe diversity or variation are basically called measures of variability. Researchers often use measures of central tendency, which we talked about earlier, mean, median, and mode, along with measures of variability to describe their data. And these are probably two of the most important characteristics as we talk about distributions themselves, both measures of central tendency along with measures of variability. Variability allows us to distinguish between what are usual data values and what are unusual data values. So by knowing something about the spread of a distribution and the diversity that it has, we're able to distinguish among what we would have usual or typical values versus unusual or atypical values in a data set. Now, when describing the spread of a distribution, there are three measures of spread that we can talk about. First, we have range. Second, we have IQR or interquartile range. And third, we have standard deviation. All three of these are different measures of spread or variability that we can use when talking about the features of a distribution according to the spread of the data. Now, let's begin with range. The range is the distance between the lowest value and the highest value in our data set. One big advantage in reporting range as a measure of spread is its ease in calculation. To calculate the range, we first place the data in ascending order. Once our data is in ascending order, we calculate the range by taking the maximum value minus the minimum value. And notice when we do this, regardless of what our data entries are like, when we take the maximum value minus the minimum value, we always get a value that is positive. So when calculating range, we take the maximum value minus the minimum value, and this value will always be positive. Now, interquartile range, we abbreviate it IQR, is the distance between the third quartile, which is the 75th percentile, and the first quartile, which is the 25th percentile. One big advantage in reporting IQR as a measure of spread is its resistance to outliers. The value of the IQR is not affected by the presence of outliers on either end of our data set. To calculate the IQR, the first thing we do is we place our data in ascending order and find the values of Q1 and Q3, our first and third quartiles. And the calculation is very simple. Once again, like range, we subtract two values. For the calculation of the IQR, we're going to subtract Q3 minus Q1. Notice, just like range, that IQR is always positive. And we often refer to the IQR, the interquartile range, as the range of the middle 50% of data. Now, to understand the third measure of spread, standard deviation, we must first introduce the concept of a deviation. Now, we briefly discussed deviations in our measures of central tendency, and we're going to continue to talk about deviations here to represent the concept of standard deviation. Now, a deviation, once again, is the distance a data point is away from the mean of the distribution. To calculate the deviations, the first thing we must do is we must calculate the mean of our distribution. Now, if we're dealing with a sample, the calculation of a deviation can be found by taking the actual data point, which we're going to call x, and subtracting off the mean of the distribution. In this case, we're dealing with a sample, so we're going to call the mean of this distribution x bar. So once again, the deviation is calculated by taking x minus x bar. And recall, from the earlier lesson, we saw that no matter what the distribution looked like, the sum of the deviations will always be zero. Now, let's